All right, guys, we're back with section 6.3, elimination using addition and subtraction. So you solved systems of equations using substitution, and we also did it by graphing. And now we're going to solve systems of equation using elimination with addition and also using elimination with subtraction. We'll talk about what all of that means. And that's the new vocabulary word, is elimination. And eliminate means to basically to get rid of. So if you add equations or subtract them in a system, it's called elimination. So step one is to write the system so like terms with the same or opposite coefficients are aligned. In other words, you have a column of x's, a column of y's, and a column of just numbers. Add or subtract the equations, eliminating one variable, then solve the equation. Substitute the value from step 2 into one of the equations and solve the other for the other variable. Then write the solution as an ordered pair. Okay, first thing you want to do is check. Do you have a column of x's, column of y's, and a column of just numbers? Yeah, I do. My x's are aligned, my y's are aligned, and my numbers are aligned. Okay, so notice that the 6y and the 6y here have opposite signs. Okay, so you just add the equations together, just like an addition problem. This is allowed. You're allowed to do this. It's pretty cool. So the 4x and 3x would give you 7x. The 6y's would cancel, and you'd have 35. And then divide by 7 to get x equals 5. Okay, then from there, it's just like when we did substitution. Take that answer, plug it into one of the original equations to get the other variable. So if I take my first equation and substitute 5 in for x, you get 20 plus 6y equals 32. Subtract 20. You have 6y equals 12. Divide by 6. And you get y equals 2. So the solution is 5, 2. Since there is a single point, the system is consistent and independent. All right, here's a couple for you to try. Go ahead and pause the video. All right, we're back. Notice that in 1a, the columns are aligned. In other words, I have a column of x's, column of y's, column of variables, or column of constants. So if I just add those together, the 4x's cancel, and I'd have negative 2y equals 2. Then divide by negative 2, and you have y equals negative 1. And I take my negative 1, plug it into one of the other equations. So I'm just going to do the first one. So you have negative 4x minus 3 equals negative 3. And you have negative 4x. So if I add 3 to both sides, you would have negative 4x equals 0, which means x has to be 0, which is allowed. X can be 0, so your solution would be 0, comma, negative 1. Okay? All right, let's talk about the other one. Notice in this one, the columns are not aligned. So what I'd have to do is rewrite this. Now, here's how you do it. You have 4y plus 3x equals 22. Doesn't matter if you have a column of x's, then a column of y's, or a column of y's, then a column of x's. So all I'm going to do is flip around the second equation to put the negative 4y first. So you always have to take the sign with the number. So the 3x doesn't have a sign with it, but it's understood to be positive. So you would have negative 4y plus 3x equals 14. If I add those two equations together, the y's cancel. I have 6x equals 36. Divide by 6. You get x equals 6. Then you could put that into the first equation for x. So you'd have 4y plus 3 times 6 equals 22. So 4y plus 18 equals 22. Subtract 18. You have 4y equals 4. Divide by 4. You have y equals 1. So the solution is the ordered pair 6, 1. All right? All right. So we can use elimination to find specific numbers that are described as being related to each other. So negative 3 times one number plus 5 times another number is negative 11. 3 times the first number plus 7 times the other number is -1. Find the numbers. All right, kind of crazy stuff. So -3 times one number plus 5 times the other number. -3x plus 5y is equals -11. The other one is 3 times the first number, so 3x plus 7 times the other number, 7y equals -1. So that gives us our two equations. Notice the coefficients of the x's are opposite, so 3 and -3. So that screams to you, use elimination, because you could just add those together, cancel the 3's. 12y equals -12. Divide both sides by 12, and you get y equals -1. Then from there, it's just like substitution. Put the -1, and we're going to put it in the second equation for y. And you would get, add 7 to both sides, 3x equals 6, divide by 3, and you get x equals 2. So our solution are the numbers 2 and -1. All right, if I check those, I can put 2 and -1 in the first and second equations, and they should both satisfy both of them. Okay, the sum of two numbers is -10. -3 times the first number minus the second number equals 2. Find the numbers. Go ahead, pause the video. All right, the sum of two numbers is -10. So that would be x plus y equals -10. -3 times the first number, -3x, minus the second number, minus y, equals 2. Notice the y's have opposite coefficients, so I'm going to add. So this x is understood to be a 1x. So 1x plus -3x is -2x. The y's cancel, and I get -8. So divide both sides by -2, and get x equals 4. So if x equals 4, I can use my first equation, x plus y equals -10. So 4 plus y equals -10. Subtract 4 from both sides, and you get y equals -14. All right, so the two numbers are 4 and -14. You can list them as an ordered pair in terms of x, comma, y. All right, cool. All right, guys, that's it for this video. Please stay tuned for the next one.